Okay, what we want to start out is looking at our absolute value inequalities. And so we'll talk about something along the line of the absolute value of x is less than some number, and the absolute value of x is greater than a positive number. And in this case, we're going to be talking about it being less than or greater than a positive number. If uh, c turned out to be a negative number, then we would have to uh, look at it in just a little bit different way. Now, when we first started talking about absolute value, we talked that it was the distance a number was from zero regardless of the direction. So when we talk about that the value of x is less than the amount of c, then we're saying if we have our number line and we know that we're going to be talking about the two boundaries, negative c and positive c, just like we would in numbers. But in this, you're wanting all the values for x that their distance from 0 is less than the distance c is from 0. So that would be talking about all the things that were between those two values. So if we put some numbers to that, let's just say we had the absolute value of x was less than 4. Well, we're wanting all the values, all the numbers whose absolute value is closer to 0 than 4 and negative 4. So if we look at those, we're talking about these numbers. Well, let's just stop and think. A number that's in that interval is negative 3. The absolute value of negative 3 is 3, and 3 is less than 4. If we talked about positive 2, the absolute value of positive 2 is 2, and that's less than 4. So what we look at is in between are all the values that are closer to 0 than 4 is. Well, when we talk about a greater than, we're talking about all the values, all the numbers whose absolute value or whose distance is further away than c is. So again, if we look at negative c and positive c, our two values, whatever those are, then we're wanting numbers that are further away from 0 than that number is. So we would talk about all the values greater than c and all the values less than negative c. So again, if we took the absolute value is greater than 3, then we're wanting all the values with negative 3 and 3 as our borders, whose absolute value is more than that, all the numbers who are further away from 0 than negative 3 is. Well, those would be the numbers that were less than negative 3 or the numbers that were greater than negative 3. So using our interval notation, we would have this. If I took a number here, negative 5. Absolute value of negative 5 is 5, and 5 is greater than 3. If I took a number over here, 6. Absolute value of 6 is 6, and 6 is greater than 3. So these are what we mean when we look at our absolute value and what that means. The way we would write these in interval notation, this one would simply be, it's the numbers between negative 4 and 4, which is very much like that. For here, we have to write it in two separate ones. This would have been a union. It's this or this, and it can be here or here. And so if we're looking at that, then it's going from negative infinity to negative 3, or it can go from 3 to positive infinity. So as we look at these, a less than is uh, an intersection. It's what's common to both of those. And a greater than is a union. It's what's in one or the other. It didn't have to be in both of them. A less than would be an and statement, and a greater than would be an or statement. Now let's look then at how we would go about solving these. And you're going to have to be sure that you set these up correctly. The way that I would want to set it up, let me just write it in words. If I have the absolute value of x is less than c, then if you remember that was our between statement. So x, whatever's inside those absolute value bars, is going to be between negative c and positive c. Then we have a compound statement that we can solve. If we have the absolute value of x is greater than c, that was an or statement. And so you can set it up into two separate equations. You have to set it up into two separate equations. X is less than the negative, or x is greater than the positive. Now there's several ways that you can look at this, and I'm just going through and showing you one of the ways. But this is what you will need to remember as you go through and you set up your inequalities. So let's look at a problem and set it up. Let's say that we have the absolute value of x plus 3 is less than or equal to 4. Okay, the thing to notice is your sign. Your sign's going to tell you how to set it up. It's a less than. So we're going to set it up as a compound statement that whatever's inside our absolute value bars is between the negative of this number, or the opposite of that number, and the positive. And we put the negative on the left side. We go from smaller to larger. Now we solve. So we're going to subtract 3 from all of our parts, which gives us negative 7 is less than or equal to x, and x is less than or equal to 1. So it's all the values between negative 7 and 1, and it includes negative 7 and includes 1. So there we have it in interval notation on our graph. We have negative 7, 1, and then we would simply use our square braces and what's between them. Solve this one. The absolute value of 3 times x minus 1 over 4 is less than 6. Now, the one thing you have to recognize is we don't distribute, we can't do anything inside these uh, as we go through to work it. We want to set it up first, then we'll take care of what's inside. So it was a less than. So that means then that it's going to be between the negative, whatever's inside our absolute value bars, and the positive of that number. Now you start looking at the center and decide, well, I've got this fraction. I don't want to deal with that, so I'm going to multiply all my parts by 4. That gives me negative 24 is less than 3 times x minus 1 is less than 24. Now we can go through and work this. And again, you have a choice here. We didn't talk about this much in our linear because it was easier just to distribute it. If you want to, we can start solving for this by dividing everything by the 3 first. Or we can distribute the 3. If we went through and divided everything by 3, we'd have negative 8 less than x minus 1 is less than 8. Or if you're not comfortable doing that, then distribute it. Let's just go ahead and distribute it because that's what you're used to doing. So 3x minus 3 is less than 24. So we will add 3 to all sides. Negative 24 plus 3 is negative 21. And 24 plus 3 would be 27. Then we'll divide everything by 3. So we have negative 7 is less than x, and x is less than 9. In interval notation, it doesn't include the endpoints, so it would be negative 7 to 9. But we go through and we set them up and we solve them the same. Uh, we do have problems where let's look at a greater than. Both of those were less thans. So if we look at a greater than, we have the absolute value of 3x minus 8 is greater than 7. Okay, it's a greater than. So on our greater than, if you remember, we have to write two separate statements. You cannot get by with writing one. You must write two separate statements. And what we said was whatever was inside, I'm going to put it over here, was greater than the positive, or it was less than the negative. And it's kind of a case of when we did that negative, we switched our sign. And there's another way that we could look at it that you would actually see that that's what we're doing, is we're multiplying through by a negative, so we actually switched the sign. So our sign switched when we did the negative. So we have two separate statements, and we solved them separately. So we'll add 8, have 3x is less than 1, divide by 3, x is less than 1/3, add 8, so 3x is greater than 15, divide by 3, x is greater than 5. This is an or statement. You have to write two separate answers. It's less than negative 1/3, so it's coming from negative infinity to 1/3, or starting at 5, it's going to positive infinity. Graphing it, we would have it's less than 1/3, or greater than 5. Now, none of these had coefficients in front of our absolute value, so let's look at one that does. Let's say that we have negative 3 absolute value x plus 3, x plus 7 is greater than or equal to negative 27. Now, we cannot distribute. This absolute value is not an operation. It's talking about a specific quantity. We cannot distribute this negative 3 into there. So we have to get rid of it, and to do that, we're going to divide both sides by that coefficient of negative 3. And we have to do that first. So here our negative 3's cancel or become 1, and we're left with the absolute value of x plus 7. Now we divided both sides of our inequality by a negative, so we have to switch that sign of inequality. And we have 9. So now we have the absolute value of x plus 7 is less than or equal to 9. It's a less than. So we can set this up as it's going to be between the negative 9 and the positive 9. Now, there is another way you could have set this up. And let me just talk about it for just a second, and then we'll go through and solve it. We know that this is an or statement. We've talked about that. So you could say whatever's inside is less than 9, or And again, we can do the negative, whatever's inside is greater than, we're going to switch it because of the negative, is greater than negative 9. Well, if x plus 7 is greater than negative 9, then isn't negative 9 less than x plus 7? That gives you the same thing, but it would be using that same step that we did on the less than, when we had or on the greater than, excuse me. When we had our problem a while ago with the greater than, if you remember what we did for the negative is when we dealt with the negative 7, we switched our inequality. And so you can do the same thing on this one and write it into two steps, but your conjunction is an or. And then it's easier to solve if it's written in this form. So we'll subtract 7. We get negative 16 is less than or equal to x, and x is less than or equal to 2. Interval notation, square braces. And then we have an okay, and we use our square braces. And we could uh, graph it. If we graphed it, then we have our negative 16 and our 2. And we're talking about what's between them. But you do have to get rid of that that coefficient first. If you were adding or subtracting any number to both sides, uh, you would have to get rid of it also. Let's look at one other thing that can happen. Let's say that our problem was 9 is less than or equal to the absolute value of 4x plus 7. Now we can't work with it in this form as easily as we can the other. So one of the things that you need to notice is when you switch the order of an inequality, such as 2 is less than 3. If we want to switch that around and put the 3 here and then the 2, notice our direction of inequality changed. If 2 is less than 3, then 3 is greater than 2. If I'm older than you are, then you're younger than I am. And anytime we do a comparison and we switch our order of comparison, we have to switch our word of comparison. So if I want to switch these sides so that it's in the form that I'm used to, I have to change my inequality. So we change our inequalities when we multiply or divide both sides by a negative number, or if we switch our order of inequalities. Now, it's a greater than, and so we set this up into two separate parts. Whatever's inside, if I'm going to put the negative, then I have to switch my inequality is less than the negative, or whatever's inside is greater than the positive. Solving, we would subtract 7. We get 4x is less than or equal to negative 16. Divide both sides by 4. X is less than or equal to negative 4. Subtract 7. We have 4x is greater than or equal to 2. Divide both sides by 4. X is greater than or equal to 1/2. This one we would write it's less than that, so it's going from negative infinity to negative 4. Here it's going from 1/2 to positive infinity. We can graph it all on one number line. We have our negative 4 and our 1/2. And this one is less than negative 4, so we're going to the left. This one is greater than 1/2, so we're talking about what goes to the right. Okay, this is solving our absolute value inequalities. What you have to know is how to set them up and how to set up your inequality as you go through and use it. Now, there's a lot of different applications for your inequalities. I know I was once trying to compare which phone card would be best. And they use different amounts. Some times you're comparing which rental car would be the best. One may just charge you so much per mile. The other one may charge you less per mile, but may charge you an upfront fee. Uh, you know, which, so there's a lot of different times that you may need to do a comparison where things are done in just a little different way. So we're going to look at a couple here just to see how that we would go about doing it. Uh, okay, we want to look at a situation here where we're going to rent a truck. And we have a choice. We can rent Speedy Truck for $260 per day, or we can rent Dependable Truck for $80 per day, but 25 cents per mile. So what we need to figure up is how many miles would we have to drive to make Speedy Truck a better deal? And so we're basing it on how far are we going to drive. So let's look at it this way. We've got Speedy Truck, and it's at $260 per day. Now Dependable, which we're probably going to call D, we're going to pay $80 plus 25 cents per mile. And what we're wanting to know then is, when is Speedy going to be less than Dependable? You know, you can tell right away up here that if you're only driving a few miles, Dependable is going to be lower and would be your better buy. We want to know, well, when is Speedy going to be less than Dependable? And so that's the inequality we set up. When is 260 less than 80 plus 25 cents per mile? And that gives us then our inequality. So let's solve it. That's an 80. So we're going to subtract 80 from both sides. And we would have 180 is less than 25 cents per mile. Then we're going to divide both sides by the 25 cents. And when we do, 180 divided by 25 hundredths would be 720 is less than M. Or if we want to switch that around, when our number of miles is greater than 720, then Speedy would be a better buy. So if you're going to be going on a very long trip, then it's going to pay you to rent from Speedy. If you're going on a short trip, then it's going to pay you to rent from Dependable. So it's a way of comparing two different ones. And there's a lot of things out there that you end up having to compare to decide. We're inundated with different phone companies and different electric companies where you're having to decide, well, which one do you need to do? So you have to set up and see, well, when will one be less? And is that how much I'm going to use? If I'm not going to be driving 720 miles, then I don't want to rent Speedy Truck. As long as I'm driving less than that, I want to rent Dependable Truck. So let's look at another one. You've got a new job offer, and you're going to be paid in two ways. You're going to be paid a salary, but you're also going to be paid a commission. So you have a choice. You can make $1,800 a month and earn 3% of your sales. Or you can be paid $200 per month and earn 8% of your sales. Well, right away, this one looks like a better one. But it depends upon what you're selling. If you're selling houses that may sell for hundreds of thousands of dollars, then you may want this one because you're making a bigger commission on your sales. If you're selling clothes, then you may want to stay with this one. So it depends upon what you're selling as to how you would decide that. So let's look at how much you would have to sell in order for this one to be more profitable, this second one. So let's look at how these are set up. So we're going to look at option A. We'll just call it A. Okay, option A, you're going to make 1,800 plus 3%. Now remember, to do a percent, we have to change it to a decimal, so that's going to be 0.03 or 300ths x. And x is going to be our amount of sales. For the second one, we're going to call it B. And you're going to be paid $200 per month plus 8% of your sales. So we want to know, well, how much do I have to sell? We want to know uh, when B, when this amount is better than A, when you're going to make more from B than you are from A. So how much do you end up having to sell? So that's our inequality that we're going to set up. It's 200 plus 800ths x is greater than 1,800 plus 300ths x. So let's get our x's on the same side. We can subtract 300ths. So this would give us 200 plus 500ths x is greater than 1,800ths. Subtracting 200 from each side, we get 500ths x is greater than 16,000. I think I call that hundredths. And then we want to divide both sides by 500ths. So x is greater than 32,000. So if our sales each month are going to be more than $32,000, then we would want to pick the 200 plus the 8%. If our sales is going to be less than 32,000 per month, then we would want to pick the $1,800 plus 3% of our sales. So when you're trying to compare, you set them up and do your comparison, and then you can make your decision. So this is looking then at solving our inequalities.